Welcome back to Trig Notes 2.3 or Pre-Calc Notes 5.3. This is the second part of the video. We're still dealing with solving equations, and this example is asking us to solve for x when we have the cosine of x over 2 equals 1 over the square root of 2. Now what's going to be different about this problem is that they're giving us a domain. So in most of our problems we'd come up with our angle and we would say plus n 2 pi or plus n times 360. Because they didn't give us a domain. They wanted us to find all solutions. Well, here it asks us to give a domain between 0 and 2 pi. So x values are between 0 and 2 pi. So that means one time around the unit circle, which means I don't have to put that plus n 360 or plus n 2 pi. The other key to this is that it's telling you how to give your answer. You must give your answer in radians because that's what the domain says. So we're not going to give our answers in degrees. We'll have to use the radians from the unit circle. So algebraically, if we're going to solve this, I would recommend that you change it first to be written as half x. So what I'm going to do when I try to solve this is I'm going to look at this problem as if it was just the cosine of x. But understand when I solve it for x, I'm really have found what half x is. And over on this side, I'm trying to find angles that have a cosine of 1 over the square root of 2. Well, 1 over the square root of 2 is not on my unit circle, so we need to rationalize. So it ends up becoming square root of 2 over 2. So let's look over here at the angles in radians that have a cosine of a square root of 2 over 2. So I see pi over 4. And I see 7 pi over 4. So what that tells me is that when we solve this, we said that x was equal to pi over 4 and 7 pi over 4. But technically, we weren't solving this as if it was cosine of x. It was really half x. So half x is equal to this. So if I'm trying to solve for x, I need to get that x by itself, so I need to get rid of that half, so I'm going to have to multiply all of these answers by 2. So this would make pi over 2, and this would make, let's see, 14 pi over 4. Which, if I reduce that, will end up being 7 pi over 2. Now here's the thing that I need to remember when I'm solving this, is that my domain was between 0 and 2 pi for x, then my domain, when it's half x, is between 0 and pi. I have to take half of it. So I really only want to know angles that are in this first or second quadrant. So right away what that tells me is that this 7 pi over 2, I can eliminate that as being a correct choice because it's not in my domain between 0 and pi. So it's going to be really important that you pay attention to what your domain is. And if you're dealing with something other than just an x, normally we're taking the cosine of x, but here we're taking the cosine of half x, you have to change your domain to make it be half x as well. And so with that being said, I was able to eliminate the only choice being pi over 2 as my answer. I want to check that just to make sure that that's right. So in my calculator I'm going to hit cosine of pi over 2 divided by 2. I'm going to put that in parentheses. And then when I type that in my calculator, I should get 1 over the square root of 2 as a decimal. And when I type this in, I get 0.707. When I type this in my calculator, I get 0.707. So that checks out. Again, you want to make sure that your calculator is in radian mode, otherwise it will not check out. Alright, looking at this next problem, it says the domain is between 0 and 2 pi, so now I need to give my answer in radians, and I don't have to include that plus n 2 pi for each of my answers. The other thing that I'm going to notice is that I'm taking just x here, so I don't have to worry about changing my domain at all. As I look at this problem, if I could write my problem as 2n squared plus 3n plus 1, I know how to solve that. That would be factoring using the box method. Problem with my problem is that instead of having an n squared and an n, I've got a sine squared and a sine. So what I've done to get this is I've made the substitution, let n equal sine of x. And then what I'm going to do is I'm going to solve this algebraically by using the box method, and then I'll go back and I'll change my n's into sine of x, and then I could solve that way. So again, I'm just making that substitution by taking out these signs and putting just n's in the place of that so I can actually solve this. So using the box method, I ask myself what multiplies b2, adds to b3, that'd be a 2 and a 1. So in the front of the box goes a 2n squared, in the back goes a 1, and then we put a 2n and a 1n in these two boxes here. Pull out the greatest common factor going across. Looks like n goes across there, and 1 goes across here, and it's positive because this box is positive. Going down this row would be a 2n, and down this row would be a 1, and it's positive because that box is positive. So we can say that this factors down to 2n plus 1 times n minus 1. And if I was to solve this by setting them equal to 0, we would end up with n being equal to negative 1/2 and n being equal to positive 1. Actually, I take that back because that was a positive. N would be equal to negative 1. Sorry about that. I wrote that down wrong right there. So now what I want to do is I want to come back and look at this. If I said that n was the same as sine of x, let's change that to sine of x equals negative 1/2 and sine of x equals negative 1. And so now I can figure out what values have a sine of negative 1/2. So looking over here, sine of negative 1/2 appears that 7 pi over 6 does. Also, sine of negative 1/2 would also be 11 pi over 6. What angles have a sine of negative 1? That's just going to be 3 pi over 2. So those are my answers. Before I circle those, I'd want to take the time to plug them into my calculator to check them out. So if you're plugging them in the calculator, it should look like this. 2, and then sine, let's say I put 3 pi over 2 in there, squared plus 3 sine of 3 pi over 2 plus 1. If you type all of that in your calculator, you should get it to equal 0. Do the same for the other two angles as well. Check them all out. They do check out as long as your calculator is in radian mode. Again, the reason I don't have to put plus n2 pi with all of these is because of my domain. Just ask for one time around the unit circle. Alright, for this problem it says solve for x, cosine of x plus 1 equals sine of x. What I'm noticing first about this problem is I have two different trig identities. And at this point I don't have any substitutions that I can make that I could change a cosine into a sine or a sine into a cosine. But I do know that there's an identity out there that says that sine squared x plus cosine squared x equals 1. So I know that I can, manipulate this identity a little bit, and I could change my problems into all sine squareds or all cosine squareds if I had the squareds in my problem to begin with. So the way I'm going to start this problem is I'm going to square both sides. And the reason that I'm going to do that is what will happen here is I'll have to FOIL this when I square it. And when I FOIL it, I'll get a cosine squared x plus 1 cosine x plus another cosine x would make 2 cosine x, and then plus 1. This side just gives me sine squared x. Now what I can do is look at this and say cosine squared cosine and sine squared. I can change this into the Pythagorean identity that says that 1 minus the cosine squared of x is what sine squared is. So I'm going to change sine squared into 1 minus the cosine squared of x. Again, the reason I'm doing this is that now this problem has one trig function in it, and that trig function is just cosine. Let's move everything over to the same side so that my problem is equal to 0. So 2 cosine squared x plus 2 cosine x equals, cancels, 0. Now to solve this, you want to factor out the greatest common factor. In this case, that would be a 2 cosine of x. So when I divide that, I'd get just cosine of x. I divide that, I'd get a 1. And now I can individually set these equal to 0. So here I'm going to end up with cosine of x when I divide by 2 being equal to 0, and cosine of x being equal to -1. So let's go to our unit circle, where all the cosine values of x equal to 0, that would be right here. Again, my domain says it's between 0 and 2 pi, so I want to give it in radians. So it would be pi over 2, and also 3 pi over 2. For this one, where is cosine equal to -1, it appears at pi. So I'm not sure if these answers work, so I'm going to want to take the time to test them. Let's go ahead and test, I'll test the cosine of 3 pi over 2. So if we're going to do this one, cosine of 3 pi over 2 plus 1 equals the sine of 3 pi over 2. I'm not going to use my calculator for this one because I'm going to end up with some errors in my calculator. So if I just use the unit circle, the cosine of 3 pi over 2 is 0. Okay, so 0 plus 1 would give me a 1 over here. The sine of 3 pi over 2 is -1. So right away I can see that 1 does not equal -1, so this one does not work out. Let's go through and check pi over 2. So if I check pi over 2, is the cosine of pi over 2 plus 1 the same as the sine of pi over 2? Well, the cosine of pi over 2 is 0. 0 plus 1 then will give me a 1, and the sine of pi over 2 is 1 also. So 1 equals 1, so this will work out. And finally, let's test the pi. So it would be cosine of pi plus 1. Does that equal the sine of pi? So cosine of pi, if I go over here, it looks like cosine of pi is -1. When I add 1 to that, I get 0. The sine of pi is 0. So that tests out as well. So that's why it's going to be important that you check for extraneous solutions, because in this problem, we noticed that the 3 pi over 2 did not test out, did not check out. So you don't always have to use your calculator to get the answers, especially when it's something as easy as this one. I think this one is a lot easier to check it by using the unit circle versus the calculator. Okay, it says a batted ball leaves the bat with a velocity of 100 feet per second and is caught with an outfielder that is 300 feet from home plate. Find theta if you know a formula to plug it into. So this is my formula. I need to know R and V in that formula to be able to plug it in. Well, they tell me what V is. It's 100 feet per second. The range is 300 feet. That's how far I am from where this ball is being batted. So if I plug it into my problem, 300 equals 1 over 32 times 100 squared sine of 2 theta. So algebraically what I'm going to want to do is calculate this. So my calculator, I'm going to do 100 squared times 1 over 32. That ends up being 312.5 sine of 2 theta. If I want to solve for theta, I'm going to have to get rid of the 312 in front by dividing. 312.5. Dividing that out, I get 0.96. This says the sine of 2 theta, so if I want to get theta by itself, I'm going to have to move away the sine. So I'm going to move the sine away by putting it over here, taking the inverse. So now I have the sine inverse of 0.96 equals 2 theta. And then if I want to solve for theta, I would divide that by 2. So I'm going to choose to have my calculator in degree mode. And when I type the sine inverse of 0.96, get that answer, divide it by 2, I end up getting that theta is approximately 37 degrees. So that the ball would be leaving the bat on a 37-degree angle to be able to get out to my outfielder. Be sure when you do these problems, you're making sure that your units are the same. This is feet per second, and this is feet. And I believe in one of the problems on your homework, they're not going to be in the same units. So make sure you test your units before you solve and plug into the formula there.